Welcome to Model 10. In this model, we are going to speak about FRACAS and Reliability Point Zero. So again, FRACAS is a failure report and corrective action system, and the objective of this model is to demonstrate online process, FRACA process, as part of asset management. In addition, we will demonstrate the relation between the FRACAS, that the main objective is collect data, historical data about physical asset failures, as well as corrective action, and the reliability prediction based on the historical of failures. The new solution that is proposing here is that the reliability prediction is performed automatically as long as we're starting to input data in the FRACAS. That we explain later on. But let's see the FRACAS cycle from the beginning. So as I explained before, when we are implementing the asset management, considering the operational elements, we need to have a FRACAS system. So that means whenever issues that comes out from our monitoring process, if the physical asset goes down in its performance, if or some inspection detect degradation and it will set up for some inspection or actions, all such inputs will come to our failure report. The failure report, as I mentioned before, need to be very well organized and make the operators as well as maintenance technician easier when they fulfill such data in the first contact that they detect some failure, or when they can perform some inspection, detect the degradation. Therefore, what we are proposing here is to have this FRACAS system online in order to enable such technicians and operators to fulfill the first stage of the failure reports, and then, of course, their supervisor and engineers, specialists will approve such reports, and you're going to see how the FRACAS system online works easily as part and need to be part of asset management. So again, that's our asset management flow. That's enable the PDCA go through the detection of the failure inspection through FRACAS until we have our assurance plan. So the FRACAS system basically encompasses this three process. So we get information or some equipment shut down, or we perform some inspections, so non-destructive tests, and we need to set up some degradation or failure reports. Then in this failure report, such failure reports is approved initially is the data is electronic inputs, and then we can use it, for example, a cell phone, because if the solution is online. It's just a matter of assets, and it's time to put data on the system. So based on it, some risk is assessed, and then we have all the failure reports based on risk rank. That's make it easier for leaders to check the level, to check the most critical one, the intolerable one, to the less critical one. And of course, there will be some failure review. And again, the risk analysis will be in the end review if there are some safety related issues, some safety critical elements related to such analysis. They will be shipped for safety management. If not, they will come out the corrective action. So basically, that is the flow of the FRACAS. And we need to consider also improvement opportunities. In the end, will also come out as a corrective maintenance, but that's not part of the FRACAS. FRACAS is related to problems, to issues that the physical asset can comes out. Okay, so when you click on the in this block here, we get the first template of the FRACAS, and then we can use a cell phone to do that. Then you can see that automatically if a user is logged in the system, that comes out his name and the date, and then he will be able to put here the issues, put the comments, and you can realize there are some fields here that the options are already input in here. That's make very easier for some technician operator to input the first failure report in the system. So we, as discussion before in this training, it's important to have the pre-definition of failure modes, and depends on the agreement that we have with the clients. There will be different failure mode definition. Uh, Usually what we have here, if there is some female, is to use the failure modes of female associated with the pipelines. And of course we have description that's also defined here, as well as inspection. So that's make faster the risk classification. So for example, when we go through the description of the failure mode cause, we already have some information put here, and then when you put this information, comes out subcode. So you can see that's the first stage of the FRAC is very fast. You can do the operators can do inputs the data in the system, not necessary to go to some paper reports, or go back to their computer in a stage, in a station, or in an administrative building to input the data, or as usual, many operators or technicians, they take some notes in some paper, and after one day they will go in a computer. When they have time, they input the data, and of course when that's happened, many data are missed, and that's not the idea. So again, we have impact classification. So we can start to put what's the impact of the failure. We have different classification here. For example, deterioration in performance. So that's the typical case that we have for vessels and pipelines and towers. For example, case of corrosion. So, and that's this type of classification will helps to address such issue for a specific group. So here again, we have a consequence as well as another classification. So we have different codes, and here we have the explanation of such codes. And here we can see, for example, safety critical issue as a pipeline corrosion. We can have a leakage of toxic products, so we put safety critical issues. And there are other classification as well. So that's enabled to make easier the life of the technician operator that inputs data in the system, and it is less than 5 minutes. They'll select what they consider that's the failure is related to, and then they click OK, and they save the system. This failure is already available in the system. Then of course their supervisor or can automatically assess and can discuss with him during this shift what is need to be done and assess this failure. Okay, so the next step is the risk analysis. Since we starting to start up the FRACAS reports with reports in the first failure, we will be able to define the risk. So in a ISO 55000, one of the important issue is define the risk criteria that's enable the asset managers, the leaders, to prioritize which are the most important actions. So in our case, operational risk will be very simple, and we use the concept of the risk matrix. And depends on the organization, of course, we can have a different risk matrix. We just consider that an example, and that's make very easier, because just to click in the fields when we remember that's the risk assessment assess the impact. So here we are assessing which impact we consider concerning safety, environment, production, and operation. So we have some hinging here, and here we have the another evaluation in terms of frequency or money, and then we can understand what's catastrophic, what's severe, what's moderate. Similarly, we can assess, and then we can, of course, in this area of impact, we can define that is catastrophic for operational issues, and then we can choose one risk. Here is the similar classification, and then, of course, we can have the same for probability, and then combination of both will have higher risk. And in the end, of course, as long as the time pass, different physical assets have different risk classification from the non-tolerable risk some to the non significant risk. This green one, we have different types of risk classification, and of course different assets. And that's the main challenge for asset managers, is to prioritize which are the ones that they need to focus first and invest to mitigate first than other. Of course, based on the risk concept, we need to mitigate, you must mitigate the non-tolerable risk, so we focus in the red ones first, then we go to the yellow one, that's medium, and then we go to the low risk if it's feasible to mitigate such action. So here we can see an example again, the pipeline corrosion. There is some, and then that's already the result of the report. So asset risk concerning leakage, and we can see here that in this stage there is no risk assessment. So that means the operator or the maintenance technician just set up the first information in the FRACAS system, but did not make the risk assessment. And after the risk assessment is performed, this time to be highlighted here in template. And then, of course, their supervisor can do this analysis if they do not complete and check in the field. And then we will have such information updated. In the end, the supervisor needs to evaluate the risk related to such physical asset failures, and then they will adjust to get in the stage that they are evaluating. There are some, then they will see there are some information already put here for the operator or for the maintenance technician, and then they need to evaluate, to analyze the risk, and to check or propose some mitigation. So let's take a look on it, what this each field means. So here we have the pipeline corrosion. The risk is leakage that can trigger catastrophic consequence for safety environments. And the comments, the pipeline corrosion was detected based on infrared during inspection plan implementation. So, and then of course now the supervising are assessing that, and then they check the risk that was applied for in terms of impact for this situation here, for this physical asset failure. He was trying to put some cost loss, and of course supervisor will have more time to do that, have some information, and then as much as information that they put in here concerning probability of having this consequence happen 8% by his judgment, and then he go further on, analyze the risk, so we can put a priority. He can put some reports in here associated. He puts the owner of this action, some operator, some inspection. Then we have the status, and of course he can go further and put cost benefits, and that's one important information that will enable to assess the mitigation of the risk. Again, just the similar template, just showing the risk. This template usually is assessed by manager or supervisor. And then here an example of risk matrix defined. So as I mentioned before, we do not define not only the impact, but also the likelihood. So now they are assessing, they confirm the risk, or they can change the risk. The supervisor or the managers can change the risk if they agree. And of course, sometimes need to discuss with the operator, with technician. They need to do a meeting. You can see here executive team. So that means one team sat down to discussion about this risk. And then now you have a risk level here very high. And then what needs to be done is the next step. So you go further in your risk analysis. Another point is very important to assess how is the proposed action after the risk after the implementation of the mitigator action, as well as the cost benefits for this action. So here is an example of templates that you uh, put the mitigation activity. So here you describe what needs to be done, and of course you need to put the cost benefit with such mitigation action. So here one example, the pipeline will be replaced, and the cost one is $50,000 to mitigate estimate investment, and the cost benefits will be a 9 here as the cost benefits. And then, of course, that's such a cost benefit action related to this risk will be also linked and related to a group all physical assets that have some risk associated with their failure. And then the manager will easily be able to mitigate the risk. Again, the same template, the residual risk now, after the replace, we have the low risk, then based on it, we confirm and we just apply the risk after the mitigation. The further step that need to be done is, of course, not only the risk assessment, we demonstrate the complete risk assessment, but also to understand what was the cause of such failure, such degradation in this equipment. Then we can go to the next step and implement a root cause analysis. So here, just to demonstrate now, after that the supervisor implement the mitigation and assess the residual risk and the cost benefits, the template with all risk associated with all issues in the FRACAS will be ranked as low. And then, of course, when we implement the mitigation, then the manager needs to follow up that and be sure that such action will be implemented. Uh, just more information about FRACAS, we can, of course, input more uh, information about the type of equipment. That's very important to have this type of information, which system, which subsystem, the type of events, the dates that's happened, if it's a critical element, and so on. And if we want to perform a root cause analysis, we can go further and perform a root cause analysis. So here, an example, what is the equipment profile that we are consider. So here is a case of tank seal leakage in a pump. It's a pump here that have some leakage. So we also need to go and complete, when you're doing the FRACAS, in the end, we need to complete this template to have a clear idea about which are the equipment. And whenever we save such information is automatically in the system. The root cause analysis, as I mentioned before, is also very important. And in this kind of pipeline is very important for the asset integrity manager follow up such action, mitigate action. So when we implement root cause analysis, we need to define who are the investigators, the team, which are the problems. And here we have some fields to be complemented. So for the timeline analysis, the failure mechanism, clear understand what's happened, and then we can go step by step. And in the end, we have some instruction and we open an issue based on such instruction, based on the root cause analysis. That is the real corrective actions. Again, just some here, some highlights. When we input the the corrective actions based on the root cause analysis, whenever we go to this FRACAS system, we have already information about here and here updated in the system. And when we click in here, we'll be able to see what was done in terms of root cause analysis. And here we see the root cause analysis results as well. Is very simple method, is the 5 whys and the automatically online in the system. So that's also enabled that employees in different location. You can invite an expert, and then you can have a web meeting and discussion about such issues, and in the end have the final root cause to understand very well what's happened with this such equipment. So here, for example, that was the first event that are were input in the system by the technician, maintenance technician, was external corrosion degradation. Then after the discussion, they considered that this pipeline was aged. There was corrosive material contact with the pipeline, humidity environment condition, lack of inspection, and lack of repair. So that's triggered this pipeline gets close to the thickness of the corrosion. And now, of course, that supports the actions that was to replace this pipeline. So we can also go deeper and just define the failure mechanism, the failure cause, and mitigate activity and description what was done, and all this detail online. That's very important because that's enable that the supervisor follow up their team activities, the result of inspection and preventive maintenance, as well as in the end of the day or in the shift, the supervisors can look on his team or in the system anomaly and check which were the issues raised, and all the leaders in asset management will follow up such actions. And if they disagree, they can modify such information, they can start submitting to discussion, and then they always keeping tracking the actions and the issues that can affect the system performance achievement. The most one important issue that we discussed before is that for leaders, whenever they look on the system, of course, every day there will be new issues. And for them to open the FRACAS system and open the file one by one and read is almost impossible. They need some tool that enable that to visualize in terms of risk which are the most critical, and then based on it they can focus in their area of control, or physical asset they are manager, they are responsible to manage it, and their team are implement actions, and then based on it they prioritize the actions. So if we have a anomaly system, a visualization like that, we can already see, for example, when the anomaly is defined by system, if you are responsible for cargo slot tanks, you can see there are some issues here in red, high risk, some in green, and some of them that you still need to be reviewed. So that's make easier the life of the supervising leaders. So they will just look on here, see if there are some big issues that will bring to a non tolerable level, a high risk, and then of course they can start to look on the high risk first, and after that look on the low risk, and then they focus the activity to mitigate such risk here. Done, since he is done here ready, he is sure that their team are look on it, they can check and verify if the risk classification for this action are proper classified. Maybe some of them are also ready need to put in here, but that's make very easier and faster for the leaders to look in their group of assets they are responsible, the system they are responsible, which are the big issues every day, and prioritize and start to manage his team. So here, and again, if you look on the on the on the critical issues related to the, for example, oil storage, we can see that there was one pipeline corrosion in red. So that's cargo and slot tanks. So here that belongs to this cargo and slot tank. So here there is a pipeline that that has a corrosion. So when they click on the red region, that comes out automatically the issues that are related. Here there is only one issue, can be more than one issue. And in this case, that's more than one issue. It's very important that they are able to see the cost benefits in order to give some priority of this action. Not only the risk, of course, if they had, in this case, it's easier because they have only one non-tolerable, only one issue in classifying the FRACAS as non-tolerable risk. But if they have more the one issue they need to prioritize, which one bring the best benefits for the investment in terms of mitigation. And then that's why it's important that the leaders input the data of cost benefits that's enable to mitigate such a risk. And in the end, of course, they will have their reports approved and updated with the responsible the anomaly concerning the anomaly system and all the issues. So for you have a clear idea when I mention about the risk. So here we can see in the graph related to cost benefits. The all the non-tolerable risks. So we have a lot of points in red. Each point is related to one issue that is open in a FRACAS system and have non-tolerable risk. The question is which one we need to implement first. So based on the cost benefits analysis, we start to implement from the right to the left, from the top to the bottom, all those risk analysis. So in this first line here that we have the higher risk, we implement first this one because bring the best benefits, best ratio of cost benefits. After this one and after this one. Then we go down and start from the right to the left, again the right to the left, right to the left. So that gives an idea how you prioritize the non-tolerable risk. So in many cases, when you do not have this type of tools, manager implements the one that have the highest severity or the ones that they have easier to implement in order to mitigate more non-tolerable actions faster in a short period of time, or even the ones that are easier, not related to investment, but are easier, they are faster, and then they start to implement the ones. But in the end, you are not sure if you are doing actions that bring the best cost benefit for your company, the best value. And that is one of the targets that we define always in our strategy asset management plan. Because of that, when we include the cost benefits in the FRACAS system related to the risk and the mitigate action, we will be able to prioritize each actions and concern also the benefits of such implementation. Now that we know which action need to implement, we go to the corrective action flow. So we already detect some failure in our inspection. That was a pipeline and non-destructive test detect the corrosion and thickness of the corrosion. We open an issue in the FRACAS system. Then we classify some risk related to such corrosion in this pipeline, and then the anomaly system defined in red clearly for supervisor leaders see that there are some issues related in red. Then of course the risk is reevaluated and approved for the manager, and then in the end we need to have corrective actions. So the corrective actions, we also have a system. So and that is our uh, first issue that we had in our when we perform all the FRACAS assessment concerning the risk evaluation, and then now we need to open an order, working order to mitigate such risk. So that's very important. Then now we have a working order open in the system in the that's also very interesting because in different locations we can open this order, and the responsible all the responsible employee that is are responsible to open a working order have access to the state system. So as long as the manager approved the mitigate action, they can open a open order. And of course they need to fulfill the title when they start this action, describe that you need to replace some pipelines, and you need to put the discipline, how many, describe the group of the actions that need to take place. So here, for example, pipeline replaced, priority one, work type is a corrective maintenance, preventive maintenance, the status and the dates that is made to the end. So they have some dates to implement that, and the description. There are more after to implement that you save in the online system, of course, information available for everyone, and then such work order can be checked by manager and they can follow up. And of course, you have a work order list. If you click in a working order list, you see which are the issues and the working order that is already need to be implement. So pipeline working order, that's already in the system. So there is automatically have a number. When you create, that's automatically creates a number, and the title is pipeline replace. So you can come out here. You can come here in this template and open and see the issues. And of course, in the end, you have your corrective order, more details. You have not only labor, you have specialist requirements, you have priority, you have material and equipment, and the service that needs to be done. So you have different fields, all electronics. You fulfill that and open a working harness. Okay, what needs to be done after that is when you have a FRACAS. So FRACAS enable, as already presented here, to have a clear idea about which are the issues, how important and critical are the issues, so you are able to assess the risk, and after that manager will evaluate the risk, approve. Will be open some working orders for such corrective mitigation actions, and then of course you have your FRACAS complete. But the FRACAS, whenever you're starting to input some data and you have the interval of time that such failures happen, you are able now to predict the reliability. Usually, the reliability analysis is applied based on the lifetime data analysis. So now, lifetime data analysis needs to be implemented through these 5 steps. You need to understand the type of sample that you have. If you have grouped data from different equipment to predict this type of equipment reliability or not. If you want a specific equipment, that's usually in a process case. What type of data, if there are complete data, you get data from this equipment whenever it fails, and all the data that this equipment shows is when it's failed, or you have a right sensor when you have group data, one of such equipment did not fail. Then you need to have complex goodness or fitness tests. Since you defined the type, the data sample, the type of data, now you're going through good enough fitness test that objective to check if which are the functions that fit better in such data, but you have different good enough or fitness tests. So depends on your data, you need to apply one of such methods, depends the software that you have, and usually such analysis apply as software. So that means more than having knowledge in statistics, you need to get a license for software. The software needs to be available, and then once collect the data, you do this goodness of fitness test, and then you predict which are the PDFs that better fit in the data. So we have 10 PDF types here. You can have more, but in the end, you need to predict which one fits better in this data, and then you are able to plot to define PDF parameters. So, for example, you can predict if an exponential PDF, the failure rate, or if available the eta and beta parameters, or if it's a normal, the mean and standard deviation. So all these analysis to predict the reliability. So you need to be a reliability engineer and be an expert to perform such analysis even using a software. When you have a software, it's supposed to be easier. So that's an example of a software to predict reliability. So those are the interval of failures of such some equipment, some pump in hours. So you need to here define your goodness or fitness tests. Here we define the regression methods, and then by applying that you can or choose one PDF, or based on the rank you define the PDF that is better fits in such data. So in this case was a viable two parameters. You have here the beta and eta. Then you need to get this based on this parameter. In this case, in the software, you plot in here automatic the reliability, and also you can predict the reliability in a specific period of time just using the software. But you need to use a software, you need to be an expert. The idea of reliability 4.0 is as long as you have input data in a FRACAS system, more than 3 data, the system is automatically make this calculation and predict the reliability and demonstrate. So the technician and the operators, everyone will have an easier life with reliability now, because it's automatically demonstrated and will come out in your screen. So let's show that how our solution use that. So every day we have our boards, performance boards overview in here. So in operation availability, we have the operation availability along the days in 1 month or different months in a year. Then some days you can have shutdowns, system unavailable or not. But of course, based on it, every day you have any reports. And if you look in the day reports, you have a list of equipment that have some issue in this day. So let's take a look on this pump E. If you click in here in this option to check what's happened in this pump E, you will have the historical of the failure in this regarding this pump. Then automatically when you put the entrance service here, the failure events, the software will automatically calculate the time between failures, the time between repair, and automatically when you put some hours here, they will predict your reliability, your operation availability, your expected time to repair, that's mean time to repair, the expected time to failure based on reliability growth methods is additional method to predict the interval between failure trends, as well as the expected number of failure, consider all the degradation. And also they predict the beta and eta. So you can see here, this beta and eta from the variable to parameter is similar what we have here. So beta 1.786, 1.79 is 11,158. So exactly what we've got here based on our prediction. Based on these two parameters, of course, now I can predict the reliability. That is the target. So the operator will check in here, just clicking and update, and need to have your targets, parameter for your targets. You can put as a constant, or our reliability engineer can input the information based on their best equipment. And then, of course, you see if your line reliability is below the targets. So here is unreliability is above the target is better than what's happened if your failure rate. And of course, you can also have additional with the same information based in different calculation. Of course, you can have the prediction of failure intensity, of the trend of mean time between failures decreasing, and the cumulative number of failures. And of course, that based on that, they calculate the next time to fail. So that's all the basis for that reliability 4.0 provides, and need to be linked to the FRACAS system and enable that everyone fastly can check if the equipment is lower than their performance or not, and what is the performance if you're achieving the warranty, and let's make it easier for everyone to understand and proper predict the reliability index. Now it's not needed to use MTTF anymore or other index and wrong calculation, because the proper calculation is automatically done as long as you input data in a FRACAS system. So thanks for your attention to attend this model. We demonstrate all steps that a FRACAS system need to have, as well as the advantage to have a FRACAS online system that's make it faster for technician, maintenance technician operators to input data in the system, as well as for managers look at such data and approve and open faster and working order. In addition, we demonstrate as well the advantage to have the reliability prediction automatically calculated and plotted based on the FRACAS input information. That makes it simple, easier, and more reliable the prediction of reliability, and that is available for all employees that are part of asset management. Thanks again. So let's move to the next model.